Looks good. Double broadcasting right now. It is April 14th. We are on chapter 14. We're talking about sorting and searching. About to go into Inception. Here we go. All right, looks like we're broadcasting okay. I'm going to turn off my media so that I don't hear myself echoing over and over again. And I'm going to switch to being on YouTube. All right, we're on YouTube only. We had broadcasting pretty cleanly there. Okay, great. All right, the next thing that I would like to do is I would like to go over the calendar with you. So to do that, I'm going to open up a calendar window on Canvas. So let's run through our checklist as well. And I'm going to do that in game because I don't have my checklist document open separately. So I will walk over there and just read it off. If I can get over there, there we go. All right, activate your VPN. I got mine, check. Set up, find a quiet location, check. Turn off notifications on your phone and computer. One check, and for me, I am now got my notifications off. Put on headphones, check. Shut down extra apps and browser tabs. I am shutting down the ones I don't need. So that I have enough bandwidth to be able to do class well. All the messaging apps, all the spreadsheets, all the documents, and good. Actually, I don't need OmniGraffle today. Waiting for everything to catch up. There it goes. Okay, I'm all set. All right, open Canvas. We got that ready to go. Open Eclipse. I think, I'm not exactly sure how Eclipse is going to go down today, but we'll let that ride for now. Open Firestorm and rebake your avatar. I'm doing that. And go under World and Environment and set it to midday. Great. Go to the classroom, make sure you see name tags, make sure you check in on the attendance machine, and then we should be good to go. Did I tell you all why we're doing checklists? I can't remember which class I was in where I was talking about the checklists. Okay, well, stop me if you've heard it again. I'll say it again. Oh, waiting for Ben. Okay, so here's the story. When I was in the military, I was in the Navy. I drove ships. I was what's called a surface warfare officer, which is when you think of the Navy, it's sort of like the traditional Navy. It's not jets or JAG or SEALs or anything. It was just I was on a ship. I was on the bridge. I was driving warships around, and we would do all these kinds of complicated operations. So, for example, one operation we did was called an UNREP, and it stands for Underway Replenishment. And what would happen is you'd have another ship come alongside you, usually a fuel tanker, a fuel ship, and come alongside. In the case I'm thinking of right now, it was a destroyer, although I was actually on both sides of the equation at various points. And you'd shoot a line over to the other ship with a modified gun, and then you'd rig a high line, which is like a zip line between the two ships while you're underway, and then you would thread a big fuel hose across on the zip line from the refueling ship to the underway ship. It's a really dangerous operation because you plug in the fuel hose to both sides, both ships, and you start transferring fuel from one ship to another. While you're underway, you're very close, and so it's very dangerous for big ships to be as close as you have to be in order to get that to work. Plus, you're transmitting, your pipe pumping flammable liquid from one side to another. So to do operations like this, we used to have checklists, and the checklists You're exhausted when you're in the military, especially if you're deployed or in combat or something. And so the checklists, you just would go through and make sure everything that was ready was ready. Make sure you had safety watch on, on patrol. Make sure you had your radars up. Make sure you had the people at the appropriate stations, the watch stations. Make sure you had your radio ready to go. Make sure you had connected in various ways. And then at different points in the procedure, you'd have different sets of checklists that you would go to. And so this was how we made sure that we didn't make any errors when we were on our ship, and make sure that as tired as we might have been, we would go through all the steps rather than having to remember all the things that you have to do. This has been used in medical environments as well. So in particular, I'm thinking of a study where maternal mortality, the deaths of women in childbirth, uh, and or their baby I think it was just the moms actually, were reduced by something like some amazing amount, like 20% in some particular environment, by putting a checklist on this emergency station of supplies that was moved around to different birthing rooms. So surgeons, residents, doctors get very tired, nurses get tired as well. And so there'd just be a checklist of things to go through. Make sure you have these various medical gear. Make sure you have gauze. Make sure you have, I don't know, syringes, whatever it is. Make sure you've wiped down, sterilized this. Make sure you've sterilized that. And they reduce mortality. It's a crazy simple thing to have a checklist, but it reduces mortality by a significant amount. So like what we're doing here isn't quite as life or death, but same thing. We get tired, we get complacent, and so having a checklist of going through and making sure all the technology is set up correctly helps me to make sure that the technological experience is smooth, especially as you've got to juggle VPNs, and I've got a whole bunch of recording software and everything else that I've got to make sure are running. So that's why we do that. Okay, let's take a look at the calendar. Make sure we've got our class up. So right now I'm broadcasting the calendar on Canvas, and we are on for April 14th. You have a Techni due tonight for chapter 13, which is about recursion. You have turned in your first drone challenge, and you turned in a Sudoku participation last night. In the chat, can I get a little feedback about how the Sudoku went? What were takeaways? I haven't had a chance to grade it yet, so I haven't seen your result. Anything you want to say about that? Infinite recursion error. Yep. That's not terribly unusual, but it probably has to do with the end case, because infinite recursion happens when you don't have a clean end case. Okay, we'll see what else comes up here. The next thing I would like to go over, as you all are typing those answers out, is I would like to go over our next drone assignment. So the next programming assignment that you have due is Monday coming up. It's drone challenge number 2. So I'd like to read through the explainer for that. Checking in on your results. Some of you, let's see, reread your code many times, couldn't find anything, but also 1 a.m. Went well, took a long time to complete for Faith. There seemed to be a lot of setup for the amount of recursion content that was presented. Yeah, I mean, true. On the other hand, it was an actual solution using recursion. Few errors, but got it working. Pretty cool. Okay, great. All right, here's the setup for Drone World 2, our problem assignment. So you've done Drone World 1, and it appears that your software from part 1 has drastically changed the landscape of self-flying taxi drones. It is clear that software can be created to control drones, and the competitors have taken notice. Suddenly, the sky is filled with new competitors. It's time to up your game. Now, you need to improve your software to stay in business. Several companies are now competing with you for passengers. The word has gotten out, and more people are using your services. Fortunately, you also have built several new drones to accommodate the influx. In this assignment, you're going to create a Java class that controls 5 drones in a simulated Santa Barbara and compete to provide the best service. The number of waiting passengers has increased to 100 people, and at this point, your drones can still only carry one person, and they can fly an indefinite amount of distance without problems. So what I recommend doing for this one is to, depends how facile you are with GitHub, but what I recommend you do is you save your code that you wrote from part 1 and you put it in a different location outside of Eclipse. And then you delete your drone 1 project and you start over fresh. And you follow these instructions with an empty project directory in Eclipse, because there's a difference here where you have to download a different branch from GitHub. You need to download Drone World 2 for students instead of Drone World 1 for students. When you do that, you're going to get the competitor drones and you're going to get a setup that reflects the background story that I just read, namely 5 drones and 100 passengers. Otherwise, most of this is pretty straightforward, is the same. You can run JUnit test to make sure it's working, and then you run your simulator to see that it's going with the default case. So let's see. Anything particularly different here? This should all be the same. Should all be the same. That's all the same. That's all the same. That's the same. All right, slightly different rubric for part 2. So when I run it, you're going to run against 3 reference controllers. So those are controllers that I've written, but you're not going to be running against other students. And so this time around, in order to be in the top half of the grading scheme here, you need to beat one of the reference controllers, and that means you need to deliver more ninjas or the same amount of ninjas faster. Let's see. And then you can beat 2 of the reference controllers and you can beat 3 of the reference controllers. Let me see if I can show you what that looks like. Where's my Eclipse? All right. I've got Eclipse up and running. No, I've got Eclipse up and running. I don't have Drone World up and running. Let's get that going here. All right, so this is my Eclipse instance on screen, and I have Drone World in my project here, and I know I'm running the right code because if I look at this, I can see the tag that I checked out from GitHub. It is the Drone World project, and it is Drone World _02 for students. So the similar setup, the reference is the same with my simulation controller, all that business here. And what I'm going to do is I'm going to run it as a Java application. Remember, this isn't a Java FX project, so we don't run with the Maven build. We're just running with normal Eclipse build. And it'll take a second to load up the models because I think I have a full high resolution simulation ready here. So as you're thinking about writing your controller for this next assignment, the place to start is where you left off in Drone World 1. I said that you have 5 different drones, and that's accurate, but you just have one object that's controlling all 5 drones. And I'll show you the difference here in a moment. Let me let this run, and then I'll show you what happens. Any questions in the meantime? Let me see where we're at. Frank asks, why are there errors for some of us even though you wrote the same code? You didn't write the same code. You think you wrote the same code, but you've got typos or something in it. If everyone had exactly the same code, you'd have the same outcome. All right. Here we go. Waiting for it. There we go. All right, so here are all of our drones. You can see I got several models there. You can see that down in the bottom there are now some competing drone controllers. You've got the 4 that I've written. One's called Randomness Incorporated. One's called Promiscuous Drone Company. One's called Greedy and Associates, and the other one's called Long Distance Promiscuous Drone Company. It's roughly related to how the names are roughly related to how the algorithms work. Generic company is the one that comes out of the box, and I think that's the one that I can't remember exactly what it's doing, but you can see it's not doing very well compared to the reference controllers. The reference controllers have delivered those in the green, and they currently have the part that's red indicates ninjas that are in transit at the given moment. So now because you have 5 controllers and 1 company, that red bar can represent as many as 5 different ninjas because although each drone only has 1 ninja, your company may have multiple ninjas at any given time. See ninjas in waiting down at the bottom, those represent all the ninjas that are anywhere. And I'm not sure who we're following here. We're following promiscuous drone 4. I'm not sure which algorithm that is. Ninjas in waiting are dropping down to 0. We'll let it run its course here. You can see generic company is not doing very well against the competitors. All the ninjas have been picked up, and so some of the drones get frozen, but those drones that still have passengers are allowed to keep running. So there should be 2, and there's the last one. Okay, so as soon as it's done, the window closes, and then we see what the results are here. And we can see all the results, and all passengers were picked up by a drone. You can see it's not sorted, and then here it's sorted by results. Greedy and Associates delivered 31 passengers in a time of this many, killed none, quarantined none, still have none on board, and unaccounted for were 0. So in this case, Greedy and Associates won this particular competition. Let's take a look at generic drone, my simulator controller. Nope, my drone controller. There we are. So this is the one that reports its name as generic company, and so that was the one that did not do particularly well. This is what you'll get when you download the software, and that's why I recommend keeping your result from your first assignment in a separate place outside of Eclipse, so that when you download the software for part 2, you don't accidentally overwrite it and then destroy it or lose the progress that you had before. So I said you're controlling five different drones. How does that happen in the context of this class? Well, there's one class that gets instantiated that does all of the controlling for your drones. And so there are 5 drones that are in the world, but 1 controller. And the way this works is that drone idling is going to get called anytime any one of your 5 drones are idle. And what's going to get passed into the method is which drone is currently idle. So if you don't want to do anything different between any of the drones, you just want sort of a generic algorithm that's going to work with all of the drones at the same time, you don't have to do anything different in here with respect to the different drones. So you can look at the name of the drones if you'd like to get the drones have an ID, and the drones have a name, and they have a couple other properties that you can use to identify them. If you want each drone to be making its own independent decision as it's idling, then all 5 drones can use the same code here. If you did want the drones to do different things depending on which drone it is, you would have to put some kind of an if statement here at the beginning, probably after super drone, maybe at 51. You'd have to say if drone equals drone 1, then do this. If drone equals drone 2, then do this. If drone equals drone 3, then do this. So if you wanted drones to do something different, you would put in an if statement there, checking to see which drone is currently idle. Or any of the other callback functions, you could check to see which drone is currently experiencing whatever event that you currently have. If you would like to keep track of information that's persistent between multiple calls to your controller, then you can create an instance variable in your class if you'd like, that keeps track of whatever you're interested in keeping track of. And that enables you to have information that persists between different drone calls. So for example, maybe you'd like to, I don't know what you'd like to do. Maybe you'd like to keep track of something that maps a drone to some state. And this is my info, and that's going to equal a new hash map that maps a drone to state. Drone to state. Come on. All right, so now I have an instance variable called info, And when the first time that this controller is called, it will get initialized. And then from then on, I have a map called info that I can use down in my controller. And so I could use it to store information. I could say info dot, it's not completing because I didn't. State would be a class that you would have to implement. Let's just, instead of state, let's just keep track of a string, for example, here. All right, do my imports. And now down in drone idling, if you want to keep track of something, you could say info dot put drone the info I care about. Or you could look at what info was put there before. And so that would be the info that you stored before. In between successive calls, you can keep track of information in an instance variable if you'd like. All right. Now that said, you can probably just turn in your code from part 1 as part 2, but your grade's going to drop because it's probably not going to perform really great against the other drones unless you do a little bit of upgrading along the way, improve your algorithm a little bit. All right, let me see if you have any questions about the drone controller stuff or about part 2. Okay, sensing no questions, what I want to do then is I want to shift gears and talk about chapter 14. So let me pull up the slide deck for that. Where to go? All right, I gotta track it down, sorry. All right, I'm gonna load it up. All right. All right, so we're going through chapter 14. We're gonna work on thinking about sorting and searching. This might be helpful for you as you're working on your drone controller. There are various ways in which you might like to sort and search through the different places or drones or people for different things or different properties. And Java provides some really nice resources for being able to do this. I want to talk about this kind of in 2 ways. One is talking about the way in which Java does sorting and searching, and how it implements it, and then how you can use it. As we're starting a new chapter, I should have a Dodger report, but because of all the stuff going on with vaccinations, I apologize, I don't. I will follow up on that when I get a chance to. And what I'd like to do is I'd actually like to go to the end of the chapter and start there, because that is where we talk about how we do sorting and searching in Java classes. And then I think what we'll do is we will look at some COVID data and try and do some sorting and searching with COVID data together. Yeah, let's give that a shot. All right. So Java will do sorting for you. There are methods that are implemented in the Java library that do sorting and that do searching. This is great because we don't want to reinvent the wheel every time. We need to sort and search. So Java has that part of the library. So we're going to stand on the shoulders of people who came before us. At the same time, we need to make sure we understand how sorting and searching are done. It's a very fundamental aspect of programming, and it's a very good place to start to think about running time and how long it takes to do things on computers. Because just because you have a method that you can call doesn't mean it doesn't use resources, and doesn't mean you don't need to know the impact of that, why it runs a really long time, for example. So although we're going to go back and we're going to talk about all of these different sorting and searching algorithms, when you go and you work with Java, you don't need to write them yourself, or Python. Same sort of, basically every language has sorting and searching algorithms built into it, and that they're all using the same underlying algorithms, although they're being implemented in different languages. So to do our sorting and searching, we're going to use methods in the arrays and collections classes that are built into Java. The arrays class contains some static sort methods so that if we wanted to sort an array of integers, for example, we could do that by doing what's here in the first yellow box. The first line represents assigning an array of integers to a variable called a. The three dots there aren't Java syntax, they're just representing some way of getting an array of integers. You could do a literal there, or you could do a method call that returns an array of integers, a variety of different things. But if you want to sort that array, what you can do is you can use the arrays class, capital A arrays, and call the method sort. This is a static method, and that's why we're using the name of the class rather than an instance of the class in order to do the sort. So you'll notice on the left side of the dot sort method is a type, not a variable, not a reference to an object. That is the way that you call static methods, and those are methods that don't require an instance in order to run them. And that's why we say static at the beginning of those methods. So the one that you're most familiar with is the main method. Main methods that you use to launch programs are static, and they don't need an instance of a particular object in order to run them. When we call .sort, we pass in the array that we care to have sorted, and it's going to sort it in some particular order. It's going to sort it in what we call the natural order. And natural order sort of sounds like, oh, of course it's going to be one way or another. It's not obvious necessarily what that natural method is, but in the case of integers, it's going to sort them from lowest to highest. And so that presents an interesting dilemma. What if you don't want your integers sorted that way? What if you'd like them highest to lowest, or evens before odds, or something like that? Well, just arrays.sort isn't going to do that, but there are ways that you can make that work. If for those of you who are interested, Java arrays method uses an algorithm called quicksort as long as your array is larger than, I think it's 8. If your array is larger than 8 elements, it uses quicksort. And we'll talk about that. And you can look up special topic 14.3 if you want to know a little bit more about the details of that in your textbook. That's an array. We know that there are multiple ways to keep track of lists of things. And if we use the Java Foundations class, the Java Collections, JCF, Java Collections framework, there we go, we would use an array list. And an array list is the object-oriented version. And so we, in the second yellow box, we have an array list filled with strings. We have a reference called names, our local variable, and we fill it. Those three dots, again, represent filling that array list with a set of strings. Now we'd like to sort them, and so instead of calling arrays.sort, we call collections.sort. It's also a static method, but because we're not dealing with an array, we're dealing with an array list. And because collections is the parent of all of the Java Collections framework classes that aren't maps, I guess. The maps aren't. Collections isn't a parent of the maps. We call .sort also a static method, and we pass in the array list that we want to have sorted. Notice that in both of these cases, they sort the collection or the array in place. Another way that these could have been designed is they could have been designed so that they return the sorted array and they don't actually change the array in place, but that's not the way they work. When you call them, you pass in the parameter, which is a reference to the thing that you want sorted, and it gets sorted. So there's no return value on either of these sort methods. They're sorted in place. The collections class uses the merge sort algorithm, and you can look at that if you'd be interested in doing that. Okay, both arrays and collections also contain something called binary search methods. And binary search methods are very fast searching capabilities to find out whether or not there is a particular element in your array or in your collection. And when you call your binary search method, like we see here in the yellow, so line 1 creates an array of ints called a. In V, we just set an integer equal to 7. And then we ask for what is the position in A of the value of 7. 7 is not present in the array A, and so we get a value back, which we'll interpret here in a second. If the element is found, binary search returns the index of where it is located. If it is not found, it returns a negative number. And so the way that you know whether or not something is found or not is you check to see whether the answer is 0 or positive. And if it's negative, it's not just that you get a negative number back saying it's not present. The negative number actually has information in it, and it tells you where that element would be if it had been properly positioned. And so the way we understand that to work is that it returns negative k minus 1, and that means that k is the position where it should be. So negative 3 is negative 2 minus 1, and 2, therefore, is the position where it should be. So index 0 has the value 1 in it, index 1 has the value 4 in it, and index 2 has the value 9 in it. If 7 had been present, it would have been found in position 2. Okay, so why that? Why would it be in position 2? Because binary search requires a particular assumption, and this is critical. This is why binary search is fast. Binary search requires that the array or the collection that you are searching over is sorted. If your array or collection is not sorted, binary search doesn't work. If you would like to search an unsorted array or collection, you just have to do a for loop. You just do a for loop, you go through it, and you check to see if it's found. But in an unsorted array or list, you have to look at every single position along the way, right? If it's sorted, you can do like the guessing game, sort of a guessing game approach to it. So let me just demonstrate that for a second. Okay, let's see. I'm going to switch to in-game audio. Boop. So we just did a demonstration of binary search by doing a guessing game. And the thing to observe that we observed was that it's much more efficient to split your search space into two each time rather than going through each element of your search space and asking if that's the thing that you're looking for along the way. In the case of sorting and searching in an array, if it's not a sorted array, you just can't do that splitting action. Because if these numbers were shuffled and it was like 4, 1, and 9, you can't like pick the middle one and then go left or right because you don't have any guarantee about what the things to the left or the right are. But when it's sorted, you can be sure of that. All right, so that's something that binary search, that's built in. But if you tried to do it, if like, for example, you called line 3 int pos equals arrays.binary search a comma v, and a is not sorted, your answer is going to be like meaningless because it's going to try and run a binary search on an array that isn't sorted, and you're just going to get a random answer that's not helpful at all. Okay, so if we are interested in sorting something by the natural order, we just call sort. And what we can the reason let's see, we can do that whenever the thing that we are sorting can be compared to another thing that we are sorting. So if we want to sort an array of integers, that's easy enough to do because we can just tell whether or not one integer is higher than another integer by doing a less than or greater than. And strings, we can tell whether one string should be higher than another one, or really alphabetically before or after, also by doing a greater than or less than. So generally speaking, we can do a sort on any kind of array list or any kind of array where the elements in that collection implement the comparable interface. So here's the comparable interface in yellow. This is an interface, and if you say that your object extends this, what it means is that you in your class have implemented a method called compareTo. And what compareTo does is it looks at the current instance in which compareTo is implemented, and it compares it with a second instance which is being passed in as a parameter. So it compares this and other. And what compareTo needs to do is it needs to return a number, an integer. And here's how Java understands that. If it is a negative number, then this, or in the second bullet point there, A, if we call A to compareTo B, in that case, A is this and B is other. If it's negative, then A should come before B. If it's 0, then A and B are equivalent, and you can't tell whether one should come before another. And if compareTo returns positive, then it's going to put B before A. Now this is really helpful because although it's straightforward to sort an array list of integers, let's say that you have a drone class or you have a person class or you have some other kind of class, and it's not obvious how things should be sorted. But if in your drone class or your person class, you implement the compareTo method and indicate to Java that you have extended the comparable interface, then you can call sort on an array list that contains the class that you care about. Most of the classes that come with Java that are straightforward have comparables. So for example, the string class, and there's a date class that we haven't worked with very much, but the date class is also comparable. Integer and double, those are all straightforward. But not all the classes that you make have that. In fact, none of them will. And so you need to implement it yourself. So let's say you were implementing a class called country, and you wanted the countries to be sorted by area, not by title, not by name. So you would implement your class like the first yellow box. You would say public class country. That part's clear. We've seen that before. Now we're going to add on to the end of that this keyword implements. And that means that you are asserting to Java and Eclipse that you are going to write all of the methods that are required for the comparable interface, and we're going to fill in that generic with country. All right, so what does that mean? If you're going to write and if you're going to meet that interface, it means that you have to write your compareTo method. So in this example, we've written the compareTo method. Within the class, we have a method called compareTo. It's public, it returns an int, and it takes in as a parameter other, which is of type country. And that country type there in front of other has to match the generic type at the top of your class. Comparable bracket country has to match the parameter coming in to compare to. And then in the body of compare to, we return a negative number, a 0, or a positive number based on what it is that we want to sort by. And we're going to pass that request down a level to the compare to that comes with double. And so the double class has the ability to compare two doubles. What is the design here, though, is what doubles we're asking double to compare. So our compare to that was implemented for country will return whatever the double compare method returns when we compare area, or this dot area, this is implicit, and other dot area. Implementing this will then enable us to sort by area. So then now down in the bottom yellow box, you can see that we can create an array of countries. That's our first line. It has n elements in it. And then we can call arrays.sort countries. And you can see that in that particular example there's no information about how we should sort it. There's nothing in that arrays.sort passing in countries that says how we should sort it. But the way Java works is that it looks in the country object to see if there's a compare to method implemented, and if there is, it uses that to sort. And if it isn't, and then it's going to be there because you implemented comparable. And if you didn't implement comparable, then arrays.sort is going to give an error right here at this point. All right. You can also, let's say that you don't have control over the class. So for example, in the person class, you don't have control over the person class. I've written the person class, and when you submit your drone controller, you're not allowed to change the person class, or I'm going to ignore it if you do. So if you wanted to sort persons according to, I don't know, their state or something, you can't write a compare to class. You don't have control over the internals. You're not the implementer of the person class. But nevertheless, you would like to sort person classes in a particular way. And so what you can do is you can write a comparator, and a comparator is a class whose only job in life is to sort a particular object. So for example, at the top, arrays.sortArray will sort the array that's passed in according to the compare to element. If that class doesn't have a comparable interface, didn't implement it, or you want to sort it in a different way, then you can also pass in the comparator to the sort method. Does the same thing. Your class will return negative number if A comes before B, positive if A comes after B, or 0 if A or B are equal. After Java 8, there was a slightly different method that was implemented in order to do this same work. So this is the third of three methods. The first one was compare to, the second one is a comparator, and the third option is what's called a lambda expression. It may be familiar, if you're familiar with JavaScript, this is a closure. It also goes by the name, what other names does it have? Closure, lambda expression, anonymous function, a couple other names that they have for these things. But basically what you're doing is you're passing in a function as a parameter. So here's the syntax for it. If you would like to sort an array of words, you can pass in the red bit here as shorthand. And what you're doing is you're defining a function by writing the red code here. This function takes in A and B as parameters, and what it returns is a.length minus b.length. So this is a really fast way of sorting a list of words, not alphabetically, but according to their length. Because if a.length is a low number and b.length is a high number, the result will be negative, and so A will come before B. But if a.length is a high number and b.length is a low number, the result will be positive, and so B will come before A. If a.length is the same as b.length, the result will be 0, and they will be equivalent in the sorting. So this is called a functional interface. These are called lambda expressions, and what is happening is Java is writing a function for you. This is a shorthand way of writing a method or a function. It's passing it in, and it's not giving it a name, and you can't reuse it after this particular class call. But that's fine because this is a simple helpful little functional interface. Um, these functional interfaces, these Lambda expressions, are used extensively now. They're used in JavaScript quite a bit. Um, they're a little bit hard to get your head around, I think. At least I find it a little bit hard to get my head around it, but they're very powerful once you do. All right, so let's where are we? We got 10 minutes. What I'm going to do is I'm going to have let's work through a little assessment together. Okay, how am I going to do that? I am going to launch an assessment, and we'll have it due today. All right, it's launched. And let's take a look at it. All right, so on screen is the assessment, and then I've also got Eclipse here. Great. And all right, so here's what we're going to do. We're going to look at some COVID data, and we're going to sort it in a couple ways that we care about. So you can get all of the COVID data from the New York Times on GitHub. It's all publicly available. So if you go there, you can download all the counties, states, all the case numbers and death numbers, so you can create all those fancy graphics that you see everywhere. Public data. You can get that for up-to-date stuff. But what I would like you to do is I would like you to use this particular snapshot that I took of the US counties so that the results that you get in the questions below are consistent with the way that I've graded the quiz. There are two classes here, a county class and an analysis class. They've written some sort methods for you. Analysis has the main method, and then county class is the one that's going to help us do the sorting. So here, US counties, let me download that, get a fresh copy of that. Okay, great. I'm gonna, oops, I accidentally opened it. That's not what I want to do. Let's see if I can undo that little mistake. And what I want to do is I want to go into here, and I want to go into Eclipse, and I want to go into class 35. And I want to drag and drop that data over here. Okay, so what I'm asking you to do is to create your own project, to import the analysis, or just drag and drop the analysis code and the county code from the quiz. And you'll also need to download the data. And notice that I've put all of these in different places. The data needs to go as a sibling to source. It needs to go in the project, but at the top level, because when it goes to try and open the file, that's where it's expecting to find it. The classes themselves can be in any package under source. You just have to clean up the code to make sure that it does the right thing. So let's look at analysis for starters. Analysis has the main method. Here's the main method that you're going to run. At a high level, this is pretty straightforward. We're going to call some method called getTheData. That's going to return an array list of counties. Notice it's counties, not, I say countries here, but it's actually counties. That's a typo. Sorry about that. And then we're going to sort our counties according to the built-in compare-to function in county. And then we're going to print out alphabetically what the first one is, because that's how we start. So let's make sure this works. I'm going to run main as a Java application. Boom. All right. And so I can see what my first county is alphabetically, because after line 64, I've sorted it. Great. So the first question asks you, what is the first county alphabetically in the data? All right. Then it asks you to change the compare to function to sort the counties by cases rather than by name. Okay. So let's look at that. So when we get the data here, we then sort it. So what does getData do? Well, getData is right here. And getData goes through, you can look at it if you'd like, but what it does is it opens the CSV file, which is the spreadsheet file. It creates a scanner like you've used before, but previously we've used the scanner to import data from a user. Instead of importing it from a user, we're going to get it from a file. We're going to change our delimiter. Instead of using a space, we're going to use commas and we're going to use end of line characters. And we're going to create an object that helps us to parse dates. And then we're going to read in the date and the county and the state and the FIPS number and the cases and the deaths. And those are all the different columns that come in the New York Times data. As long as the county is greater than 0, we're going to go ahead and we're going to convert all of those strings that we got into data types that we can work with. So we're going to convert our string into a date, our cases into an integer, and our deaths into an integer. And then we're going to add all that data to our array list of, which should be counties, but I spelled it wrong, countries, by calling our constructor on our county object. And our constructor is going to take in a date, a county, a state, a FIPS data, cases, and deaths. And then, so all it's doing is reading in the data, and then eventually it's returning the data that it got back. So the other interesting thing to look at is our county. Here's our county. Has basic instance variables here. That's straightforward. Our constructor does nothing other than call our superclass, which is just the object class. You can see that county implements the comparable interface. So we better have a compare to. Oh, look, here it is. Here's our compare to method. Great. And what we end up doing is out of the box, we compare this dot county to other dot county or o dot county. And because county is a string, what this ends up returning is a comparison between one string and another string. And so our default method for sorting counties is alphabetically according to the county name, which is what's getting passed in our constructor. If we want to sort by something else, then we need to change how we're comparing our counties. And that's what I'm asking you to do for the second part. So in the second part, I ask you to sort by cases and answer which county has the most cases. And so after you fix the compare to method, what will be output will not be the first county alphabetically, but it'll be the first county according to cases. You just have to be careful because if you simply do int.compare AB, you're going to get the counties sorted by cases from lowest to highest. But I'm asking you which county has the most cases, in which case you're going to have to do something that reflects, that changes that. You can either change your compare function or you can change how you output. Then finally, I ask you to sort by date. Which county has the first reported instances of COVID-19? And that requires you to change your compare to again, so that rather than comparing integers or comparing strings, you compare by date. And you should be able to do a similar static call as we do with integer, but use date as your static class instead of integer. All right. Okay, in the fourth question, I say in the main function, change the collections sort line so that it accepts an external function. All right, so this is just means that when you call your collections, I want you to call it in a different way. I want you to, rather than use the compare to method, I want you to use this third method that I talked about, which is to override the compare to method and pass in a lambda. And so what we're going to do here is we're going to call collections with countries, and you're going to pass in this lambda expression, and that's going to sort by deaths. And that's going to be regardless of what the compare to method has implemented. And then finally, I ask you to tell me what is the largest number of deaths that from any number particular country. Now notice what I've done here is I've swapped A and B. And so instead of, if I wanted it to be lowest to highest, I do A.deaths and B.deaths. But if it's B.deaths first, it'll swap the ordering. All right. So there's 4 different things for you. That you might have to look in the textbook maybe, or look in the YouTube video in order to review just the compare to methods. But that should be kind of a straightforward, 15-minute exercise. All right, so let me stop there and we will wrap up for today. That 1401 is posted in Canvas on your to-do list, and I will launch I'll get our notes for today up online and make them public in a second. That wraps up the material from chapter 14 today, April 14th. Are there any questions I can answer before dismissing you? Let's do it at midnight tonight. Okay. Thank you for your attention. Have a good day. Yeah, thanks. That sounded like Josh, maybe. All right, double broadcasting in game, shutting down YouTube. And this is April 14th, Wednesday, talking about sorting and searching. Thanks, everyone.